So now we're moving on to having a look at finding the coordinates of the center of a square or quadrilateral. Now, just to start off and just have a bit of a discussion around, what is this question really all about? Essentially, what we're trying to do is find the center of this shape. Now that you found out the midpoint, and now that you know this midpoint formula that's on your screen over here now, you may say to me, well, that's really easy. If I've got this square here, I could just eyeball that. I'd go across that x-axis and I'd be in my negative x values, so that the coordinate for the midpoint is going to be negative 3.5, and then 1, 2, 3, 4, 4.5, negative 3.5, and positive 4.5 will be the coordinate. So I'll be right smack bang in the middle of that square. But the reason that you need to know this, not only for the Year 10 syllabus, but also into future maths, is that you may get a shape that's actually being translated on its side, like this rectangle, for example. And if I now look at this rectangle, I have no idea, I have no perception, and even less perception if I take out that diagonal that I've put in there, less perception of actually being able to find where that midpoint lies. Now, as I've already touched on that, I've put in a diagonal, and the reason being that I don't find the midpoint using the midpoint of AD, for example, and I've put those prime numerals in to help me identify lines, and then also, so the midpoint of AD and the midpoint of AB, and then, draw lines in, because it's on its side. So that's going to get messy. Instead, what we're doing here is we need to find the midpoint of a diagonal. Okay, that's a much more efficient process. So if we find the midpoint of a diagonal, theoretically, I can actually find the midpoint of both diagonals, and if it's the same, that proves that that's the intersection point. And theoretically, like, if I just found the midpoint of one, that would be the answer. Then we're going to get the same answer from doing both equations, from plugging those values into both equations. But I want you to look very carefully at what I'm doing here. So with this diagonal, I'm going to call A my x1 and y2 coordinate. So x1 and y1 coordinate. And then C is going to be obviously my x2 and y2 coordinate. Running out of battery. So when we go and have a look at this formula, my AX is going to be, I've left out my subtraction over this side as well, so I better make amends over that side. There we go. So that's negative 3 here. So yeah, as I was saying, we're going to have our x1, 0, x2 is minus 3. Oh, what have I done? Oh, I've messed these up, sorry. I've put the negative on the wrong side. I did have it right before. It's just this one that we'll need to get rid of. My apologies. So this is 0 minus 3. So we're going to have a negative indice there. All right, and then we have the 3 from the y value here, y1, minus y2. Now that would be technically in the formula y1 plus y2, but because we've got a positive and a negative, it's going to be 3 minus 4. So we're going to end up with negative 1 divided by 2. We bring down that negative 0.5, and then of course 0 minus 3 is negative 3 divided by the 2, negative 1.5. So now if I go ahead and I'm just going to use those values, or those coordinates I should say, so I've actually created coordinates here. I'm going to use those coordinates to find a midpoint. So my x value, I'm going to go across minus 1.5, there we go, and I'm going to go down half points. There it is. Perfect, and that looks excellent from eyeing it where that midpoint is. Now, I did also promise that I'm going to prove, if you understand that, that's fantastic, but just like as proof that this actually works, I'm also going to put in this second diagonal, and I'm